For starters, I just want to welcome all of our attendees. Thank you for joining today for the discussion of our melanoma trials in progress. As many of you know, we've made a transition in leadership. I am handing the reins to Dr. Patel, who is going to run today's meeting. And I'm going to sit in the background and cheer at all the right moments. So Dr. Patel, take it away.
Thank you, Ken. Thank you. And we're giving you a virtual round of applause for your leadership these last 2 years. Thank you so much. So good afternoon, everyone, and welcome, virtually to Chicago in my background here. I also actually want to take this opportunity, and I'm just thumbing through the attendees. I know people are probably slowly coming on here, but I wanted to take this opportunity to thank Hussein Taubi for serving as vice chair of this committee for the past 2 years. Hussein has announced that he would like to move on and continue to fill his plate with other activities. I'm not sure that I see him here, but I'll pause for a moment. Hussein, if you're on and would like to say a few words. I think people are probably still trickling on where they are. I'm excited to announce that our new melanoma vice chair is Roger Lowe, professor of dermatology at UCLA. And Roger comes to us obviously with a strong background, clinical medicine, laboratory and pathology medicine, and he'll be an asset, I think, to our protocols and development in our active portfolio. And similarly, Roger, if you're on, although I don't think I see you, please feel free to take a moment to say something if you're on. Okay, well, we do have a busy agenda today, so I will keep things moving here. I think we're in a webinar format here, so we actually cannot clearly see the audience, I'm afraid. We can see your names, but we can't see your faces, unfortunately. I think it doesn't even let you turn your cameras on. We have a chat and we have a Q&A, just wherever, throw what you need. We'll try to man all these areas and field any questions that you have. So moving on to our opening speaker. Many of you have kept up with developments in the microbiome space and fecal transplant medicine. In popular culture, it's been on Stephen Colbert, it's been a South Park episode, and of course, our speaker's recent publication in Science. So, using large-scale data sets and multi-omics approaches for high-throughput data, Dr. Davar and his team have uncovered unique microbiota signatures, and it's for PD-1 response and also toxicity. And they're leveraging this understanding into some therapeutic advancements. So it is my pleasure to introduce from the University of Pittsburgh Medical Center, Dr. Divakar Davar. Dr. Davar, take it away.
Thank you, Sapna, for the very kind introduction. I am sorry that we're not able to talk about all of these things in person, because if we could, I have a long list of poop-related jokes.
And actually allow me to correct my pronunciation of your name, because I realized it as I said it. It's Davar, right? You prefer Divakar.
Yeah, that's okay. John Kirkwood has never pronounced my name correctly, and I've been here 12 years. So do you guys see my slides?
Yep, we see it.
Yeah. Okay, good. So these are my disclosures. And again, you guys at SWOG have done so much in this space and I'm just looking at the slide, and the number of trials that SWOG is doing and has done has really transformed, right, how we think about melanoma. So Sapna's neoadjuvant, adjuvant, Ken's soon to be published adjuvant pembro versus interferon versus IP trial, and then Zainab's trial that we are actually enrolling to right now, just to mention some of the agents that in the IO space that we're thinking about and how they transform the management of melanoma has really, changed a lot for our patients. And we've now got these, extraordinary PFS curves where a third of our patients are just durably cured with immune therapy in the frontline metastatic setting. And then now, of course, with the data and the approvals in the adjuvant stage 2 space, potentially even more patients will be cured and may never need to worry about relapse. But that still means that, up until now, we focus a lot of our attention on trying to figure out why these drugs work. And that understanding is really focused, to a large extent based on our further and deeper understanding of the genome and the epigenome, and focuses on factors characterizing the tumor microenvironment. But that still leaves out this other complete parallel set of biomarkers, right, that affect how we know the immune system is modulated, including, for example, tumor-associated factors, host factors such as HLA haplotypes that have, for example, in the context of CTLA-4, been shown to, for example, mediate the efficiency of binding of CTLA-4 via FC. And separately, what our interest is, which is the human microbiome, our second genome, that potentially can affect outcomes to checkpoint inhibitor therapy. So we really, over the last 5 years, thought of this in two parallel fashions, and they're really one story. But for the purposes of this talk, I've split them up into two things, and that is, how can you alter the microbiome in highly refractory patients? And then the subject of our more recent work that is currently under review and soon to be published, hopefully, which is, what do we know? What is the landscape of these microbiota in relation to checkpoint inhibitor therapy response and side effect development? So this idea that you can modulate it is not necessarily new, right? So data from Genwago, Tom Gajewski, and Laurence all said that you can do this in single bite in their papers in Nature using single bugs, right? So Tom's paper, single bifido, you put it in the appropriate in a mouse experiment and it will synergize with PD-1 in the setting of tumor-associated in a melanoma mouse model. And you can do this also in the setting of whole fecal transplant. So Genwago's data, fecal transplants, avatar mice that are exposed to colonized donor microbiota, they'll reject the introduced cell line, and in the context of responders and in the non-responders, they actually have tumor growth. And so we just set out to recapitulate this, right? We just did the exact experiment in humans. So I think the interesting thing that we did here is that we picked a really resistant patient population, which is why I think part of the reason why I think we were able to publish this with only 15 patients is that we picked a really highly refractory patient population. So this was the primary refractory melanoma setting. Again, we did a trial in 2015 before the SITC task force definition actually came up with this definition. But when you look at what we did, we really took the primary refractory patient population because these patients had no prior response to checkpoint inhibitor therapy, best response of PD or SD lasting less than 6 months. And again, Tony Rebus is on this call, and at the point in time in which the FDA had this, what is the responder, non-responder definition? They actually wrote him, Keith Flaherty, and John Kirkwood actually wrote this editorial, right? And actually, in our paper, we cited that editorial because it is true that the proportion of patients who are non-responders actually depends on how you define what non-response is. So again, a very strict definition of non-response, and then exposure of the fecal transplant that is donor-derived, and then pembrolizumab continuing every 3 weeks starting on the day of transplant until progression. And there was extensive serological testing that needed to be done because, it's still stool, right? So you can potentially transmit all kinds of stuff. And so patients had to be excluded if they had HIV, had B, Hep C, and that sort of stuff. And then more recently, SARS coronavirus as well was tested. But then, the surprising thing was that it was actually not that hard to do. If you screen enough people, you will identify patients who are potentially candidates to become donors and match them up with seropositive, seromatch recipients. So the first test of feasibility was actually met quite easily. And 15 patients were enrolled in the study. And that's the patient population that we reported upon. Fairly heavily pretreated patient population. Median number of prior therapies was 2, but they also included 3 or more therapies in up to 3 patients. Fairly high LDH in most patients, and mostly cutaneous, though 1 mucosal patient was enrolled. And again, fairly high, neutrophil to lymphocyte ratio pre-treatment. And so what did we find? So the first, the most interesting thing is that there were a whole bunch of people that didn't respond. That is not surprising, right? And those people that didn't respond went on to, further therapies. But again, keep in mind that the vast majority of these patients, every single patient had primary refractory melanoma. So the first thing that was kind of surprising was that we had some people that had radiographic disease shrinkage, right? So we didn't give them anything other than poop and continued pembro, and 3 people had radiographic shrinkage, and 3 more people had just non-progression of their previously progressing disease. And so to us, that was kind of interesting. It was just one of those things where you sit up and you're like, this is, it's not, I don't think, changing the standard of care. It's just, at least at this point in time, it's very suggestive of some biological phenomena that we need to study further. And you had the usual stuff. You had, radiographic CRs, a radiographic PR, a radiographic pseudoprogression that turned into a PR, and then just some people who had long-term radiographic disease stabilization. And we took as responders all the people who had stabilization and non-progression, and we lumped them all together for the sake of correlative science analysis. And the responders were durable. In fact, 3 people have actually stopped treatment and gone on to just surveillance right now. And you can see this is an example of the one patient. So 80-something-year-old guy, pre-treatment had progression of a liver lesion and a left axillary lymph node after adjuvant PD-1, come on the study, had some disease growth in the left axillary lesion. And then after 12 cycles of pembrolizumab, that axillary lesion shrinks further and then becomes even smaller after 20 cycles. And he's now just on maintenance therapy. So what did we, and what is the engraftment kinetic, and what is the, how do we explain what we found? Well, what I'm showing you is a Euclidean plot. So as I explain some of the statistics that we're doing, I will spend a little bit of time talking about these stats because, contrary to most of the stuff that we normally see, RNA-seq data, some of the stats that were done for the purposes of this are new. So I'll spend a little bit of time talking about them. So Euclidean distance basically is an approximation of time and its approximation of distance. So what you're doing in this, in basically each dot is a UMAP plot, right? So in any conventional UMAP plot, you've got 2 Cartesian coordinates that you're trying to use to describe where somebody is on by some dimension, whether it's some high dimensional statistic. So here what we've done is we've done metagenomic sequencing on all our responders, and we have metagenomic sequencing on their donors, right? And so we're trying to see how close or how far somebody is relative to the donor. And the positive distance is an approximation, coming closer. Negative distance is moving further apart. So what you see by a chi-square test is that the vast majority of donors, in fact, every single favorable responder migrated towards their donor. What is interesting is that 4 out of 9 non-responders also migrated in the direction of their donors, indicating that if you just look at metagenomic engraftment, a fecal transplant is actually quite effective, right? As you would suspect, that 10 out of 15 people actually had some kind of metagenomic engraftment, but that was necessary and sufficient in 6 people, but not sufficient in 4 people. And these changes were, quite profound, and it was more profound and faster in the people who responded compared to the people who didn't respond. The second thing that you can see is that, very interestingly, unsurprisingly, antibiotics are terrible. So this was a patient who started out, the donor pre-treatment sample was kind of hanging out here in terms of this UMAP plot. We give her a transplant, and immediately after the transplant, she becomes very similar to her donor. So this is where she was. We give her a transplant, and this is where she is. Then what happens is, for whatever random reason, she gets an antibiotic. And as a result of the antibiotic, she loses that engraftment. So she kind of goes back to where she was. And we give her a second transplant, and you could ask why, and I'll show you why in a bit. And actually, she comes right back to where she used to be. And when you do this longitudinally, you see a very nice plot. So this is kind of where she was. And what you see is that when we gave her antibiotics because of a soft tissue infection, that antibiotic use, and again, keep in mind that we're longitudinally sampling these patients, right? So that antibiotic use was actually associated with a loss of similarity after she gained similarity to a donor. So her Euclidean distance became positive, right? After you give her antibiotics, she loses that, and her tumor growth kinetic increases. You stop giving antibiotics and you give her a second transplant, her tumor growth kinetic goes back down, so she starts having radiographic disease shrinkage. And again, she has donor engraftment. So again, you can't say much of this. This is not the kind of data that you can take to the bank. But all you can say is that when you looked at this patient in a single patient case study, you can see metagenomically that there are some findings that are kind of intriguing. So what you see is that the patient had disease shrinkage that was associated with metagenomic engraftment, and then subsequently loss of shrinkage growth associated with loss of engraftment. And so the bacteria that were good and bad, were primarily the bacteria that were good, formed into the phyla that, to a large extent, the phyla that we tend to think of as good. Lactobacteriaceae, Ruminococcaceae, Bifidobacteriaceae, and Corybacteriaceae. So all the phyla that you have seen in the context of the papers that have been published by Jen, Laurence, Tom, and several other groups internationally, all showing good bacteria. And very interestingly, and data that I'll come back to later, Bacteroides, a gram-negative species, found to be enriched in the non-responders. Now, we actually did a very interesting assay to try to see whether or not, to try to convince ourselves that this was indeed a biological phenotype. And what we were able to do was we actually did bacterial translocation using IgG-seq. So basically, this is an indirect Coombs test using serum, right? So you're essentially looking for the presence of bound immunoglobulin in serum. And what you can see is that there's profound amounts of induction of anti-commensal immunoglobulin, primarily in the non-responders, compared to the predominantly the responders compared to the non-responders, and that is statistically significant as well. And what we were able to show was that all of this was associated with adaptive memory phenotypes. So peripherally, we were able to find increased amounts of CD8 T cells that had TBET and TIGIT on treatment in responders compared to non-responders. A very interesting NK-like T cell phenotype, the CD56 positive subset, and very interestingly, of course, effective memory in mate cells. So mate cells are CD8 T cells with a mucosal invariant T cell receptor. And non-responders had also higher frequency of myeloid cells following the treatment compared to responders. And then using some causal relation to identify these causal relationships, we did a transnet analysis. We were able to kind of tee all of this together to show that the microbiome metabolite change, that interaction largely mitigated what we were able to show. And then in one particular node, we were able to correlate key bacteria that are thought to be good with that were negatively correlated with bad cytokines and myeloid cells, and positively correlated with response to therapy. So that's kind of one story. And then the second story is a story that I'm more excited about. That's the work that is currently under review and hopefully soon will be published. And what we set out to do in this analysis was, we've got a whole bunch of papers that have shown that the pretreatment gut microbiome appears to be associated with response to therapy, but these bugs appear to be very different. So why is that, right? And so, this is the sum data of what we have right now. And you see all these different cohorts and you see all these different results, and you see that none of the bacteria appear to be good, but you start noticing that, all of these guys in all these different places use very, very small numbers. So small numbers. They use very different definitions of what is response and what is non-response. There are different definitions of what's good and what's bad. And they use very different sequencing methodologies and bioinformatic pipelines. Number 3. So to try to analyze and identify predictive signatures across cohorts, we came up with a large data set, our own cohort of approximately 104 patients. And at the same time, did a meta-analysis of the existing data sets using source level metadata, and had a fairly stringent definition of what response was. So again, radiographic response, but also incorporated time to event analysis to try to tease some of these things apart, and had samples that were acquired both early and on treatment to try to see if there was a difference in terms of when the samples were collected, and that made a difference in terms of what bugs were identified as being associated or not associated with good or bad outcomes, respectively. And then we did the same thing with the cohort in the meta-analysis. So the first thing is, sequencing depth does not appear to matter in terms of identifying metagenomic differences. Whether you look at this broadly and deeply with shotgun, or very superficially with 16S, you still identify, you can still segregate people who do well versus people who don't do well. And in order to infer whether or not whether there was a time-dependent nature to this analysis, what we did was we had all these patients in whom we had pre-treatment microbiome samples, right? And we had time to event analysis. So, we were able to tell responders and non-responders apart, But what we did was we plotted essentially a 1 over per-manova statistic. And so let me explain a little bit about what this is. So the per-manova is essentially the separation between two groups at 2 time points, right? So what you can do is you can plot an inverse per-manova over time to try to see whether people segregate as a function of time. And the idea, the analogy that I use to represent this is, let's say you're an alien species and you have no idea what human growth kinetics are, and you're trying to essentially infer when humans grow most quickly. And if all you had is the clothes in somebody's drawer over their lifespan of their first 20 years, say, what you'll find is that there's a large number of change, a greatest proportion of change in terms of clothing sizes in people aged 11 to 12 to 13, right? So before that, they had, a bunch of clothes of a bunch of different ages. But then between the ages of 10 to 13, all of a sudden, you find a lot of different sizes of clothes that appear to change. And that's what you can use and what you can infer from that if you're an alien species is that humans appear to grow quickly between the ages of 10 to 13. And now we know that to be puberty, but you can infer that by using a time-dependent variable to measure change. And so what we did was, when we did this, our inference from this is that the microbiome appears to exert a time-dependent phenotype upon response. And that time-dependent phenotype appears to happen kind of in that 6 to 12 month range. And there is data, we did the same analysis in the MD Anderson data set and found a time of about 12 months. So, fairly similar. And that suggests to us that the maximal impact upon this was in the primary proportion of patients who appeared to respond or not respond to therapy. And then when we did this compositional differences, we found a bunch of bugs that were good and a bunch of bugs that were bad. And these signatures of bugs that are good in blue and a bunch of bugs that are bad in red largely highlight what we've already known. Now, what we were able to do additionally was by using meta-analysis, we were able to identify non-responder specific signatures. But very interestingly, much like what Cynthia Sears was able to shown in a recent CCR paper, the concordance of responder-specific signatures was actually lower across data sets. And I'll come to that in a bit towards the end. And when you use the time-dependent analysis, you find more good and more bad bugs. And these are very favorably using positive hazard ratios or unfavorably using higher adverse ratios associated with response or non-response to checkpoint inhibitor therapy. And you can plot this on a volcano plot and identify a couple of bugs that we all know to be, fairly reproducibly seen in the data sets and in other data sets. And now we started to wonder why, whether there was an underlying explanation as to what could account for this. So, there is this idea out there, and this is data, and that's not my data. The data at the top left is from Kurt Schalper and Ignacio Malero, as well as Genentech group, using essentially several different clinical trials, both in the BMS studies, melanoma patients, as well as this data set, which is a urothelial data set, looking at high plasma pre-treatment IL-8 values as being associated with non-responsive checkpoint inhibitor therapy, this high pre-treatment IL-8 in an intratumoral myeloid program. So you could say, in this data, this is now Kurt's data showing that the same thing is found in their data set as well. And so you could ask, why were we so excited about plasma IL-8? Well, the answer was, in our previous analysis in the melanoma FMT trial, we identified this intratumoral myeloid program as an high IL-8 and as being associated with non-response to a microbiome intervention. So our question was, could it be possible that maybe bad bugs work by essentially altering the intratumoral myeloid skew and potentially also a systemic myeloid skew? Now, of course, it would be ideal if we had plasma levels of IL-8 on these people, but we did not, right? This is a real world data set. But we had something that was close, and that is a neutrophil to lymphocyte ratio, which is, exactly what you see on your CBC. And there's something like 2,000 publications right now that are talking about NLR in any setting from COVID to, pick your disease of interest. And actually, I think the best checkpoint data came from our colleague in Italy, Paolo, who showed that this is, again, a very adverse biomarker to checkpoint inhibitor therapy. And so when we looked at people with high and low NLR, yes, we were able to tell those two apart. But very interestingly, when we look at these bugs in patients with in our responder non-responder patient population, we were able to identify a interleukin-1 beta signature, again, using an approach that looked at luminal sequencing of the patients who had contributed stool specimens. We were able to identify an LPS signature that was associated with IL-1 beta and TNF alpha and NF-kappa B, indicating that this program, the CXCL8 IL-8 program, appeared to mediate a systemic inflammatory tone that is NF-kappa B and TNF alpha dependent and potentially infer non-response to checkpoint inhibitor therapy. Now, separately, as we all know, the commensal microbiota appear to be associated with the likelihood of development of colitis. And this is data from Judd and his data showing that Bacteroides and Ruminococcus are two different organisms that appear to be associated with the likelihood of developing colitis or not. And again, gram-negative rods, Jen Wilder's data showing that the mechanism by which this appeared to happen was, again, this specific gram-negative pathobionts being associated with IL-1, intestinal IL-1 beta and PD-1 or PD-1 CTLA-4 related colitis, as you've seen in a recent publication just a couple of months ago. And what we did was we did a very similar analysis where we looked at patients with metagenomes and we were able to tell these groups apart, right, using metagenomic data, patients with and without immune-related adverse events. And we plotted out all these different immune-related adverse events by categories. We found that Streptococcus, in several different organisms, but particularly Streptococcus, was very distinctly different across different categories. And so primarily side effects are driven by gram-negative rods, but some side effects are actually driven by strep. And we started to wonder as to why this was the case, because one of the key things that we came back to was the largest data set in question, Caroline Robé's presentation in the European Journal of Cancer a couple of weeks ago using the Keynote-006 data, which was to show that there was no link between immune-related adverse events, whether it's a positive or a negative biomarker. And so we started to wonder why this was the case, because you've got all these side effects that appear to be good, and these people saying that side effects are good, immune-related adverse events in particular, but could there be side effects that are both good and not good at the same time? So to answer the question, we found, we did this, and we found that strep was differentially distributed across different categories, but strep is not a gastrointestinal commensal. Strep is actually an oral commensal in your mouth, and it's not supposed to be present in the gut because it's killed by a high gastric pH, so pH of 5 or below that. So we hypothesized that maybe PPI could account for this. And so indeed, when we looked at PPI exposure, we found that the vast majority of people with high strep had PPI use. And conversely, the people with low strep had no PPI use. So we start to wonder whether the survival differences that people have seen are firstly largely due to the presence of an unmeasured confounder such as PPIs, and potentially whether some adverse events are really potentially beneficial, and whether or not if you account for this confounder, whether you might be able to explain some of the previously seen but then subsequently not seen associations between immune-related adverse events and favorable outcomes to checkpoint inhibitor therapies. So in summary, I don't want to take up any more time. I'm sure you guys have questions. We know that there's patients who are treated with PD-1 inhibitors have durable responses. Now PD-1 potentially with LAG-3 and PD-1 and CTLA-4 have durable responses to therapy, but still a proportion of our patients do fail therapy. And this failure rate happens, relatively speaking, early on treatment, that the third to half proportion of our patients who fail early. And it's very interesting that is when we see potentially the greatest impact of the gut microbiome. So again, all we have so far, a lot of associations. I don't have direct causal data, right? Because this is one of those settings in which you do not have, you can do these experiments in notobiotic mice, but there are some limitations with this kind of data. So yes, this is a very early biomarker. We're still at the cusp of understanding whether this is, even really just true or not, or whether this is just some giant association. But what we think is happening is that the beneficial microbes appear to be cooperating with other tumor intrinsic factors, TMB and interferon gamma, to sustain and generate these responses to checkpoints. But that the detrimental microbes appear to exert an effect primarily in the first 1 year, 6 to 12 months, and potentially via an underlying myeloid skew. Now, we've not seen that in primary refractory melanoma, that this potentially can be overcome using fecal transplant. Now, I'm not here to say that we should all be going and doing fecal transplants. In fact, I'd say anything but that. I think this is a very, very, literally a rudimentary, crude exercise in science in which we need to try to understand what's happening and why it's happening even further. But at the same time, we need to be very cautious because based on some of the data that some of my colleagues have generated, people have already jumped into generating consortia. And the idea that some group of bugs, whether it's 5, 6, 7, or 8 bugs, is going to cure cancer, I think is very, 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 has to be taken with a grain of salt. And particularly because when you look at the consortia that have been developed, so this is Kenya Honda's consortia published in Nature, now in clinical trials with the company known as Vedanta. When you look at this consortia and see whether or not this potentially is going to, mediate any kind of favorable outcomes, you start to wonder whether that's going to happen at all. Because when you look at the overlap between the consortia and the bugs that are present, in the overlap of the bugs that were found to be present in the data sets that other people have put out, including us, there isn't a lot of overlap, right? So it starts to raise the question as to whether this is whether it's still too early. So what we're doing is, we're still doing some very, very early experiments, trying to identify whether we can try to tease out in a methodical fashion what's happening, why it's happening, and whether we can describe the kinetic of what's happening and how it's happening. And so we've got a second trial that has been funded by Merck. And in this setting, we're hopefully going to utilize discovery approaches to both prove this hypothesis in primary refractory non-small cell lung cancer, but potentially in the melanoma patient population, try to look at whether or not we can use this fecal transplant to both ameliorate toxicity with pembro and lenva, and also mediate response. So pembro-lenva combination right now that is in a pivotal trial that has been shown to be effective, 22% radiographic response rate by Anna Rance in the LEAP 004 study. And we're trying to see whether or not we can overcome the toxicity of that, because very interestingly, TKI toxicity potentially can be ameliorated by fecal transplants. There's a paper by an Italian group in Nature Communications just a couple of weeks ago. So we now have these signatures of response and non-response, as well as side effects, and data from MD Anderson, looking at side effects to try to see whether or not side effects can be used to treat, can be overcome by a fecal intervention. And so we're now on the cusp of still trying to see how this particular signature, interlinks with other signatures, such as tumor-associated and tumor-intrinsic signatures, such as TMB, interferon gamma, as well as host signatures. And potentially start thinking about interventions microbiome interventions to try to treat immune-related adverse events. So Mike Dugan has got this really lovely paper in Cell last year with Kai Wuchefenig, looking at this idea that in T-cell poor organs, we've got loss of tolerance, but in T-cell rich organs, we've got barrier organs. We've got the idea that specific commensal pathobionts are linked with the development of immune-related adverse events. And this provocative data from Wang-Ying Hong suggesting that fecal transplants can be used to treat highly refractory colitis, and Jen Walger's data suggesting that colitis is, IL-1 beta mediated, and our data going in that direction as well. Can you think about, FMT as beyond a healthy donor FMT, as beyond a targeted approach, as an approach to treat side effects beyond just efficacy? And so, we are trying to develop this idea further. Potentially the intestinal microbiome composition, or microbiotype, or enterotype, microbiotype, potentially a biomarker, still very early, right? Not quite there yet, but potentially a biomarker response to checkpoint inhibitor therapy, PD-1 monotherapy, but potentially other IO agents as well. And maybe we're utilizing this to select patients for microbiome-specific interventions. And then trying to characterize this in terms of side effects as well. And then in the context of these discovery approaches, trying to do this in other histologies. And then we, along the way, have many other interesting questions. How this differs by geography, how this differs by ethnicity. Can we identify these consortia? And what host-specific perturbations favorably or unfavorably alter the microbiome? And what kind of consequence this has on outcomes to checkpoint inhibitor therapy? And can we control for this? So with that, I'll stop. I'll take any questions. I'm sure there are many. And thank you for the opportunity to present our work. an audience of friends and colleagues.
Thanks, Divakar. That was wonderful, amazing, a fire hydrant of information, truly. There are actually a number of questions that have come through. If anybody is interested and wants to be moved to the panelists so they can verbalize their question instead of having to type it, just send us a message in the chat, we can move you. There is a question here that came through. It was from Kim Margolin. Let me see if I can pull it. She's really asking about the recidivism rate. In the absence of the pressure of antibiotics, losing your donor phenotype, do patients just automatically revert back?
So,
does that explain
yeah, there's a great set of data. So again, in the interest of full transparency, after we published our data, there have been a couple of people out there that have gone and tried to replicate the data, and they've done a fairly good job of looking at our source data and identifying all of these things. And you can attempt to answer this question in one of two ways, and that is, it's actually a very interesting biological question because all our gut microbiota, we actually colonize kind of like in the large colon, and the bacteria attached to the bacterial, using mucin, attached to the lining of the gut, in a very, very sticky connection. So actually getting rid of bacteria in a dysbiotic state such as C. diff is actually easier than, the setting that we're in, right? And the reason is because C. diff is a perturbed state. It's not a natural state. You've given somebody antibiotics. You then got a super colonizer. The super colonizer is not a native bug. And it's actually easy to get rid of, which is why healthy donor fecal transplants work. 80% of the time, you can give somebody with C. diff a healthy donor fecal transplant, and it's more efficacious than vancomycin or fidaxomicin, which is why if you're a microbiome company, your first indication is C. diff. It's not, immuno-oncology. So the idea behind recidivism is that it's a very profound question because the bacteria that you have now, that at least people have, that maybe if you believe in this hypothesis, potentially mediating checkpoint inhibitor therapy non-response, has actually been there for a while. And so getting rid of these things is not easy. And so what we've been able to show, and we have data about this, it's actually the supplementary data of the paper, is that when you give somebody a fecal transplant, different people take up the transplant at different rates. And it's actually very interesting because when you look at it metagenomically, you can look at different time points, and we have, we are actually sampling these people at week 7, at weekly, week 1, week 2, week 3, week 4, week 5, week 6, week 7. We've got this longitudinal sample, and what you see is that people go, using a heat map, people go from red to blue over time. And not only do they go from red to blue over time, they go from red to blue variably by bacteria. So not every bacteria engrafts, and not every bacteria engrafts permanently.
How well have we studied the dietary habits of those patients you're describing? That to me, it's all probably about their fiber content and the diet, that the graft lands in a favorable diet. It'll do better.
So that's a great question, Ken. And actually, I hate to punt, but the best people in terms of diet are actually two groups, and one group actually is a SWOG site, right? So I believe, I don't know if I'm at liberty to disclose this, but I think Genwago is a paper that some of you probably know. It's a fiber paper that is currently under review, very favorably been reviewed at Science, and I think you'll see the data hopefully very shortly. And the idea is that yes, fiber is very important in mediating and sustaining this certain bugs. And whether that's being done through butyrate or short chain fatty acids, we don't quite know yet. But yes, bugs are important and fiber is important. But what comes first? Is it chicken or egg? We don't know, because not everybody. You have to keep in mind that we're using responder donors, right? And the responders, this is the Midwest, right? So they largely died on meat and potatoes. It's not like we have more people who are responding to checkpoint inhibitor therapy in the alfalfa capital of North America, which is California. That's not the case, right? It's not like it just so happens that everybody who responds to checkpoint inhibitor therapy is eating a so green diet.
So Divakar, do you have a characteristic donor phenotype?
No.
Yeah, that's interesting.
We don't have some kind of super donor person that we call up and say, hey, listen, man, I need for you to eat Chipotle every day, twice a day, so that you can come in and give us a bucket load of poop. No, we don't. We do not have that, right?
And do you suspect that these dietary microbiome sort of engraftment also relates to sort of racial ethnic diversion? So if you have more of an Indian sort of hereditary, maybe diet lifestyle, and then those microbiome, would you take for just a non-matched donor maybe?
Yeah, so I think right now we are limited by what we can do, right? So our donations right now in this entire protocol, firstly, very, very, very early stages, right? We are limited to what the FDA is going to let us do. So I think you can only make one change in a person at one time and study that change and try to understand it, right? So if I try to change the diet and change the microbiome, and I try to sell that story in a setting, I mean, people are going to say, what did it, right? So we're changing one variable, the microbiome, and we are limited by the fact that when you change the microbiome, you're limited by the fact that the FDA is going to say, well, you can't give somebody with who has strongyloides negative, strongyloides positive poop. Never mind that strongyloides positive poop. We have no idea whether that even means something. The test turning positive doesn't necessarily mean that you're going to transmit that bug. Such as it is, we're limited by that transplant. So as much as I would like to control for these factors at the level of the donor and the recipient using, say, hypothetically South Asian donors to treat South Asian recipients, I can't. Yeah. Just, we can't control for these things. So that's kind of where we're limited at. So I hope I answered the antibiotic question. And we got another very interesting question here in the context of, I think, Siwan's question about the strains. This is a very, very, very profound question. And I just want to take a little bit of time to contextualize the question and then answer it. So Siwan is asking, different studies, different strains, largely non-overlapping. Most trials, Cynthia Sears' data with gram-negative species having a better association with, meaning it's better, you've got a better negative biomarker than you have a positive biomarker. How do you explain all of this stuff? And then the second part to a question is, how do you think of the interventional trials? So let me answer the first part of the question first, which is all this overlap stuff. So let me submit to you to think of an idea first. And that idea is that the gut microbiome numbers in the trillions, right? So it's not in the millions, 6 zeros, the billions, 9 zeros. It's in the trillions, 12 zeros. So when you start to think of segregating groups, right, and finding p-values that are significant, when you have a trillion of anything, you're going to find a p-value that is significant, no matter what. I mean, that's basically the definition of multiple testing. And the microbiome is unfortunately a victim of this, right? So when you do limited analysis and say that, am I going to find in a two-group analysis, right? So hypothetically speaking, if I'm looking at responders and non-responders or any other two-group analysis, and I look for something with the trillions, keeping in mind that there are trillions of organisms in different groups at any time, I'm going to find a p-value, right? So the idea really has to be, how do you integrate this idea, all these different data into some kind of cogent phenotype? So in the next couple of months, I think you'll see two papers that attempt to answer this question. One data set is coming from the UK, Nicholas Sagata. So again, very, very smart guy, trained at basically the guy who invented Left-C, right? So if the guy who invented Left-C comes up with an analysis, I think we can believe what he has to say. And Left-C is basically the way in which you visualize a taxonomy, a cladogram. So what Nicholas Sagata is doing is he's analyzing the data set from the European Consortium of Checkpoint Inhibitor Therapy received patients in the UK. And they have got a very nice analysis that I'm not at liberty to discuss because I believe it's also under review. And then there's a paper that our group is putting out there. And what you'll see in both of these papers, hopefully soon, is the idea that geography and a mapping makes a difference. So what that suggests is that in order to understand where the microbiome comes from, you need to have an idea as to how the microbiome differs in relation to some reference point. And the idea that I would use this to explain is it's like any other two-dimensional data set, right? When you're looking at any two-dimensional data set, you need a reference point. So Cartesian coordinates, X and Y, you have something here and something here. And when you try to analyze that, you still need that Cartesian coordinate. So what we're missing right now in the microbiome is the fact that we don't know how the abundance of any given species in any given geography differs between other members of that same geolocale, because geography has not actually been studied as a measure of variability in most of the underlying data sets. So hopefully some of the data that you'll see soon will answer Siwan's question. The second part of her question, which relates to strain level analysis, is a very, very fundamental point. And the idea is that bacteria are not bacteria. Bacteria are actually groups of different bacteria. It's kind of like saying that all the Grossmans in the world are the same. No, Ken Grossman is the world's smartest guy, but that doesn't mean that every other Grossman in Utah or any other place in the country is Ken Grossman, right? And that's what we unfortunately do when we talk about bacteria. We group the Akkermansias and we group the Bifido, and we say that all of these are the same, but they are not. Bifidobacterium longum is basically Ken Grossman. That doesn't mean that it's kind of like saying that the name, right, the taxonomy, that particular bug is just describing that particular organism at the taxonomic level. It doesn't talk about the strain or the species level differences. So essentially what we're going to have to do as we do more of the science, which is why this is still very the discovery stage, is that we're going to have to do strain level analysis in order to identify which strains, and potentially in some of this work that will be published in the next couple of months to years, you guys as reviewers are going to be saying, you know what, don't come to me with Akkermansia being good. Tell me which strain of Akkermansia is good and how you identified said strain. And how did you reproducibly show that said strain in your interventional trial was identified in the responders and the non-responders, or in the donors and the recipients? So I hope that answers that question.
Yes, yeah, thank you so much, Diwakar. That's a very good point that you raised there. I think for the future microbiome studies, because there are so many other factors that contribute to this, right? So, the other data need to be collected, like the patient's diet and fiber content, and what's their eating habits, whether they use probiotics and what kind of probiotics they use, and where they live and which country they are from. All these things are important, right, to explain all of this. But I think it's really intriguing that you showed with fetal transplant, you can actually see consistent response. And you can actually salvage those patients who, who took antibiotics. And then, you can just give them a second transplant and then salvage that response. That's really remarkable. What do you think is in the fetal transplant that make that difference? That other, strain-based, medicine or, study drugs cannot do?
So, Siwan, I don't think we're doing too much. I think we're doing two things. I think people are predisposed towards responding to checkpoint. Some people have a bad immune skew. That's all. And the bad immune skew, that bad myeloid skew, this myeloid stuff that Kurt Schalper and Ignacio and Genentech and everybody is going at with, you can do this in a variety of different ways, right? You can try blocking IL-8, see if that works. But there's this idea that myeloid is important. All I think we are showing is that one contributor towards the intratumoral myeloid axis and the systemic myeloid tome is the microbiome. And by removing that aspect in non-responders, you can potentially get a portion of people who would otherwise not respond to Pembro or Opdivo or Nivo or any other PD-1 inhibitor of du jour to respond. That's all. In this experiment, that's all we're suggesting now. Could that analysis and understanding differ in the context of, say, PD-1 CTLA-4? 100%. PD-1 LAG-3, absolutely. PD-1 TKI, 100%. But that's why I think that this idea, this reductive idea that bacteria plus PD-1 is somehow going to work for all classes of checkpoint inhibitor combinations is unfortunately entirely too naive. Because when you look at TKIs, for example, TKI toxicity can be mediated by the microbiome. And you can fix TKI toxicity using a fecal transplant. That's already been shown in a randomized control trial that is placebo-controlled. that was shown by a bunch of Italians. But that doesn't mean to say that PD-1 plus TKI plus microbiome is going to be better than PD-1 plus TKI from an efficacy perspective. So the point is that different bugs may be helpful in different settings for different reasons. All that we showed in the context of this early experiment was that in PD-1 primary non-responders, myeloid cells can be depleted by removing bugs that sustain them. That's all. It's a very limited and focused analysis of just that.
Guys, in the interest of time, I'm looking at the clock here. I think we'll have to wrap it here. Diwakar, this was so engaging and intriguing. I think we have so much to learn about human microbiome and what works for one disease that could be actually detrimental for another disease type, and deliverability of FMT and these kinds of things. We have a long runway. It'll keep you busy for another, hopefully 20, 30 years. So thank you for coming here and for giving us your sage wisdom on this topic.
Well, thank you for the opportunity, and my SWOG colleagues. We are actually having ETCTN concept regarding a side effect trial. And hopefully, if that trial gets through the ETCTN, we'll be looking for a SWOG collaborator. So please keep your ears tuned for that. But thank you for the opportunity.
Great, thank you. You know, on the heels of this talk, I think it's important to hear from our patient advocate. As you guys know, Sam is really just so involved in both SWOG, ECOG. I know she's got a conflict on her schedule a little later. So Sam, if you're here, and I feel like I just saw you drop off.
I'm here. No, I'm
okay,
here.
There you are.
So,
okay.
I will be brief because I know everybody has a busy schedule today, but I just want to sort of put everything in perspective as to what you've been doing over the last year and moving forward. So some of you may have read SWOG's frontline article about the 14 million years of added life gained by adults with cancer in the US over the last 40 years, thanks to the NCI, NCTN studies. And certainly it's an incredible metric to appreciate, and it's really satisfying to quantify the benefit of all of the work that you're all doing. But I also wanted to translate what that means to patients. So, you know, you hear in your clinic about those monumental moments, seeing their children graduate high school, walking their daughters down the aisle, meaning, newborn grandchildren. But I think what's even more important are the everyday moments, sort of the mundane minutes of each of our days that makes us whole. Hugs, smiles, laughter, conversations, chatter among friends, even the quiet times when you're alone and in thought. And so, for patients, those 14 million years of added life, it seems almost too large of a concept to really contemplate. So when you think about your own daily lives and the things that you love about doing them, patients are so grateful for those moments. And so as you continue working on clinical trials and developing new ones, I really want you to fully understand what those 14 million years means to those patients. Thanks.
Thank you, Sam. Appreciate that. Let's move on to talk about our studies in development. So we're going to actually hear from both our SWOG portfolio and then also the ECOG portfolio. And then we can have a little bit of time for discussion about where we think some gaps in our portfolio might be. So I'll let Takia Trong take it away for talking about our SWOG melanoma protocol, pipeline, I should say.
Thank you, Sapna. Nice to see everyone. Thank you. Hope you're having a good day. Let me maximize my screen. Okay. So I'll start with our open studies. Our first one is S1801, which is a phase 2 randomized study of adjuvant versus neoadjuvant pembrolizumab. Patients are eligible with stage 3B and higher resectable disease. Accrual goal is 500 patients. They're randomized to the adjuvant and neoadjuvant arm, and then go in the adjuvant arm, obviously first to surgery and then receive pembrolizumab. And I'll add that for the pandemic, dosing here has also included long-term dosing. In the neoadjuvant arm, they received neoadjuvant pembrolizumab, and flexibility was also added here to allow more time to get to surgery, given the uncertainties of the pandemic. And then patients receive adjuvant pembrolizumab after. In terms of accrual, the study has done very well. Out of the anticipated accrual, we've had 276 now, 138 in the adjuvant arm and 150 in the neoadjuvant arm. There's actually been a lot of events, so we may not need all 500 patients. So if you are considering the study, I would consider it sooner rather than later, so your patients can have this opportunity. Our highest accruing sites are University of Utah, the NCORE of CRCW Michigan, the University of Michigan, Northwestern, and Kaiser Permanente NCORE, my own site. But all cooperative groups have contributed to the study. There's accrual from Alliance, ECOG, and NRG. Well, grateful for everybody to contributing to answer this important question. S2000 is by Zainab Eroglu, Moffitt Cancer Center. It's a randomized phase 2 trial of encorafenib, binimetinib, and nivolumab versus ipilimumab, nivolumab. So targeted IO combo versus IO in BRAF mutant melanoma with brain metastases. So this is a new study that just recently opened. We're very excited. If you have not opened it, you should consider it. The study schema has 2 arms. Arm A is encobini, the other arm with nivolumab, and the other arm is ipilimumab, nivolumab, which currently for those with active brain metastases that are untreated is the standard of care. In terms of eligibility, there's actually very flexible eligibility here, so lots of room to consider this for your patients. All patients with brain metastases who have a BRAF mutation are eligible unless they have uveal melanoma. Steroids are permitted up to 8 milligrams of dexamethasone a day. So that's also a lot more liberal than many other trials, understanding that this population is a little bit different, has a different steroid requirement. Even prior local therapy is allowed for brain metastases. So while this is, of course, requiring a untreated site, if your patient has other symptomatic sites, those can be treated as long as there's at least half a centimeter left that's not treated. Your patient is eligible, you know, ultimately then it just comes down to the systemic therapy, which otherwise hasn't been used before, extracranial disease is not required. So for your CNS only patients, this would be a good study to consider. So it just got started. Out of the accrual goal of 100, we have 5 patients. There's the Ozarks NCORE and Moffitt, Alliance and NRG have contributed, and we hope you'll consider opening it. In terms of pending studies, we have a concept by Tanner Johans from the Washington University in St. Louis. It's a phase 1/2 study evaluating a MEK inhibitor and the concept of autophagy for this patient population in combination with a PD-1 blockade. The primary objective is overall response rate, secondary objective PFS and OS. The agent is trametinib and hydroxychloroquine, and the PD-1 agent is tislelizumab. A biopsy is required because it's an important scientific question to answer. You know, the study will start out as a phase 1, but then ultimately go to a phase 2 design. Oh, I'm not sure what just happened. Sorry, guys. Excuse me. There you go. Next is a randomized open label phase 3 trial by Sunandana Chandra of Northwestern University. This is going off of recent data presented at ASCO. It'll be a non-inferiority study evaluating ipilimumab and nivolumab versus nivolumab and relatlimab in patients with previously untreated metastatic or unresectable melanoma. Key eligibility criteria are fairly standard: unresectable, untreated metastatic melanoma, good performance status, here, one key feature that I think is very attractive, it's allowing active asymptomatic brain metastases. This is something that we should probably consider for most of our new trials. These are the study arms, and it'll be looking at PFS and safety. The study will also be asking important questions in terms of biology, and so it'll explore important correlatives. We also have several surgical trials that are trying to improve outcomes for our early stage patients. This is the CAKE trial, complete margin assessment for excision of cutaneous melanoma. It's by Dr. Wesley Yu from Oregon Health Sciences University. And for those of you involved with local therapy of melanoma, this may not be an unfamiliar diagram. Complete margin assessment accounts for a lot of melanoma irregularity. There's the bread loafing technique, and then there's the complete margin assessment. The trial is trying to look at comparing these two manners of resection. Eligibility will include TIS, T1A, and T1B early stage melanoma, including locations in the head and neck, hands, feet, or genitalia. Sentinel node biopsy doesn't need to be indicated and can be refused. Exclusion is recurrent melanoma or a higher stage disease of T2A or higher. Last but not least, please watch out for MELMART, SWOG 2015. This will be soon to be activating. It's chaired by Joshua Mayman from Nebraska. And here, this will be a collaborative trial, international trial. And the question being asked is, there's a lot of uncertainty about what the proper surgical margin should be for malignant melanoma, particularly for higher thicknesses. And there's significant variation in practice for those having T2B to T4B depths. There was a pilot study that accrued to this concept between 2015 and 2016 with 400 participants randomized. And this was analyzed, and they found that there was a higher rate of reconstruction with 2 centimeter margin, which is not surprising, especially in areas like the head and neck and difficult to operate areas. And so this study will look at patients with T2B or higher melanomas and randomize them 1-to-1 to the following stratification factors. In arm A, patients will receive wide excision with 1 centimeter radial margin, including a sentinel node biopsy. And in arm B, it'll be the standard 2 centimeter margin with a sentinel node biopsy. Patients will be stratified by stage, age, sex, and country, and probably, in that way, accounting for local practice. And that's it. Thank you for your attention.
Thanks, Takyao. So I'm just checking the chat here. It's a question about 2015, if it's going to open before the end of 2021, I suspect. I apologize. Which study is our 2015? I know
that will be MELMART, the one that we just discussed.
Yeah. Josh, I don't know if you're on, and we can move you to the panelist if you want. The update, oh, he's here on panelist. Josh, I don't know if you want to field that. I know we've got some responses to CTEP to address.
Sure, there are some responses, but we anticipate that it will open before the end of the calendar year. And we're very excited. A lot of sites are interested in opening the trial, and we will be in touch with you shortly. I don't anticipate it'll be more than just a few weeks.
Oh, wow. Yeah, we're also very much looking forward to it. Thanks, Josh, for bringing this to the US.
So we'll hear next from David Lawson from ECOG to give us an update of their portfolio. And we can then have a discussion kind of how our portfolios may be complementary, but also where we might also want to start developing some concepts and ideas. And David, I think your slides are being shared from the AV side on our end, right?
Yes, yes.
Okay.
I hope so.
Yes. I think Jed's pulling it up. Yeah.
Yep, there they come. Okay, next, please, our first slide. One of our first proposed trials is an adjuvant high-risk mucosal melanoma trial. Next slide, please. And this is led by Drs. Luke and Shustari. It's a randomized phase 2 trial, adjuvant nivolumab, with or without cabozantinib in people with high-risk resectable mucosal melanoma. And as you can see, it's an alliance trial. Next slide, please. I think we all know that mucosal melanoma needs improved adjuvant therapy. There have been several trials looking at activity of checkpoint inhibitors and other agents, but we still have a long way to go. Next slide, please. So this is complicated, as you might expect from mucosal melanoma, because there are a lot of variables in how people approach this. The patients can have had surgery with or without radiation. They can have different PD-L1 status, different nodal status. So it's a complicated trial, and anyway, it's a complicated trial. And basically, you see the arms there: nivolumab plus cabozantinib, nivolumab alone, nivolumab, and then with crossover to nivolumab and cabozantinib, or nivolumab and cabozantinib for people who have advanced first-line treatment already. So it's a complicated treatment protocol with not a whole lot of patients in it. And so I think that also just reflects the realities of mucosal melanomas. Next slide, please. All right, second trial is a surgery trial. It's looking at sentinel node positive patients who have head and neck primary cutaneous melanomas. Next slide, please. This is being led by Dr. Gassman. I think Dr. Silk has also had some, certainly a role in this, and Craig Slingloff as well. Next slide, please. We know, I mean, we might think, and some people do, that the issue of completion node dissection is already settled by MSLT2 and DCOG. DCOG, however, didn't include head and neck patients. MSLT2 didn't have very many head and neck patients, 241. That's a pretty good number, but still it was less than was planned. And there's actually, in that small number, some sense that completion lymph node dissection actually was favored in the head and neck patients. The quality of life in people who have to have or who have recurrences is, of course, a big concern in head and neck cancer. And so these are the reasons that Dr. Gassman has been advancing this protocol. Next slide, please. And there's a split. I mean, people think they know, which is always a dangerous sign, but we think we know what's the right thing to do, but maybe we don't. And there's a pretty strong interest, at least in ECOG, in pursuing this trial. And Dr. Gassman has been pretty dogged about pursuing it himself. And of course, the other factor that's into this is that these patients are going to get adjuvant anti-PD-1 therapy. And so we don't know how that's going to affect things like local recurrence and things of that sort, which you would expect is going to be different in the two arms, just like it was in MSLT2. All right, next slide. Okay, management of primary melanoma in the elderly. Another complicated issue and a complicated trial. Next slide, please.
Good afternoon. My name is Yana Najjar. I'm an assistant professor.
This is Dr. Najjar. Next slide, please. I didn't know it was going to play.
As you can see here, only patients in the vulnerable cohort
I'll let her tell.
To either wide local
I'm sorry.
or wide local excision only.
But basically what that trial will do is it will randomize people, first assess people by this geriatric assessment as being really fit, which is the top group who will get standard of care, really frail, which is the bottom group who are going to get wide local excision only, and then surveillance. And then the somewhat vulnerable group, mild to moderate, who will be randomized to either get wide local excision and a sentinel node biopsy and adjuvant treatment if indicated, versus wide local excision only. And the idea of, and this is again, treatment of the primary. So the idea is to see if we can spare some of these elderly patients, some of the more aggressive and morbid treatments that we do. Next slide, please. All right, this is a study to look at PET as an early measure of response to immunotherapy. It's called the FLAIR trial. Next slide, please. And this is from Dr. Farwell at the University of Pennsylvania. Next slide, please. And of course, we pretty well know that that patients who have PET scans fairly soon after beginning immunotherapy will not uncommonly show an increase in FDG activity that is really a response to the immunotherapy. Next slide, please. And so the question that this is going to ask is, if you look at a PET 6 to 14 days after treatment in people with melanoma or non-small cell lung cancer, and also some other circulating tumor DNA and other markers. Next trial, our next slide, is will you be able to predict who is going to have responses? And this again, a fairly small trial, 57 melanoma patients, 57 non-small cell lung cancer patients. And what they will do is compare the overall response rates between people who have this FLAIR response and people who do not. And they've defined what a FLAIR response is, of course. Next slide, please. This is a trial, an adjuvant therapy of stage 2B, 2C melanoma. Next slide, please. This is led by Dr. Sanger. And this has a pretty heavy correlative studies component. And she's using cemiplimab and fianlimab, anti-LAG3, in combination in this group of people. Next slide, please. And of course, we've just seen data that adjuvant pembro for stage 2B and 2C can be helpful to these patients. But the differences in those curves, of course, are not very much. And that's one of the reasons for trying to be more aggressive. But at the same time, it's one of the reasons for wanting to do careful biomarker studies so that we can identify who doesn't need the treatment at all. So it's doing two things, actually. Next slide, please. And so this is some data from Dr. Hamid showing the efficacy of these two drugs together in the metastatic setting. Next slide. And this is the schema, 369 patients per arm, and then treating more or less standard of care, anti-PD-1 in the control arm, and then the study arm. Next slide, please. And this is showing what we were talking about. If you look at these kinds of patients, 60% or so never needed the therapy in the first place. Maybe as many as 20% benefit, but then 20% of them die anyway. And so this is the need for biomarkers to help us predict, particularly that 60% who never needed the therapy in the first place. Next slide, please. Yeah, and this is just a very cryptic listing of our active studies in melanoma. Gal, I think you were looking at maybe making this make more sense, but I don't know where you stand with that effort.
Yes, if you stop sharing, maybe I can just jump in 1 second.
Yes.
Yeah. Okay.
It's like the rest of my life, I have no control.
Here we go. Sorry, my computer is very slow today.
I think you and I made a very similar kind of slide, so I'll let you share this, Takyao. And we just really wanted to highlight where we think we have, where is our portfolio? You know, we heard for early stage and surgery, we've got Melmart, the cake, we've got Brian Gassman's seal, completion lymph node dissection and head and neck, Yana's geriatric study, if it's okay to call it that. And in the adjuvant space, we have some thoughts about, you know, well, I should mention neoadjuvant. Obviously, we've got a couple of protocols going between ECOG and SWOG. In adjuvant, we have the stage 2 fianlimab, cemiplimab that you just heard. We've got some ideas brewing for adjuvant BRAF. You heard about cabozantinib for mucosal. Of course, the Pembro trials. Nover, not everything's open. I mean, obviously the ones with like X's are not, and some of the others are still being developed with CTEP, et cetera. We have, you know, we have ideas for frontline metastatic. We've got PD-1 refractory trials that just closed, 1607, 1616. And we heard in working group about some concepts in that space. You know, for the first time, we've got an NCTN NRAS dedicated trial with Tanner Johann's autophagy inhibitor. We closed a desmoplastic trial, and so we'll have to see, you know, how we fared with that study. But that was actually a really important hurdle to cross to show that we can do things in the rare cutaneous malignancy space. We've got S2000 open for brain mets. It is for BRAF positive brain mets. So really, we could argue we've got a gap for the non-BRAF positive brain mets for the LMD, you know, group of patients. For non-cutaneous melanomas, advanced melanomas, we really don't have anything. You know, we don't have anything for these rare populations of metastatic uveal, metastatic mucosal, say melanoma associated with pregnancy. Now, granted, these are all rare subpopulations, but I think we can take a lesson from the DART trial and see that if there's a universal concept, if there's a universal combination that might make sense, that really hasn't been vetted, let's say LAG3, right? We don't really know the benefit of LAG3, say in some of these rare melanoma subtypes. Maybe that's what we want to do. We want to have a DART-like melanoma subgroup. So it just places for us to expand. Of course, we don't have anything in prevention, and at the other end of the spectrum, survivorship. We just heard about microbiome, so lifestyle factors could be very important here. And then, of course, when I look at this list, I'm not sure I see, well, I see the BAM study. I was going to say, I'm not sure I see a metastatic BRAF trial. So it's another area we might want to consider, but we do have that BAM study in ECOG. So interested in, you know, if there's any discussion or anything in the chat box here. We do have about 40 minutes left in the meeting. We do have to get through a few other agenda items. I know there were some questions about surgical eligibility and so forth, David, in some of the ECOG trials like R2 margins for mucosal. Some of that does happen just by anatomic location. Maybe that's what they were meaning.
Yeah, I honestly don't know the answer to those in the kind of detail that you would want to know. And I apologize for that, but I really don't know. And Dr. Sondak asked, you know, what endpoint tells us okay to spare a sentinel node in a frail patient if they die anyway. And I think I don't know exactly how they're planning to deal with those data, but I think that is part of the question. If you're going to die anyway, then you don't need a sentinel node. That's not going to stop you from dying of your heart disease, and that, which is, I think, what you're getting at. And the surveillance of the nodal basin, again, I apologize, excellent question, but I assume it's ultrasound but I didn't verify that. So I'm 0 for 3 on the question.
No, it's okay. Well, certainly as those trials become a little more fleshed out with CTEP, we'll certainly bring them back. So
yeah,
we'll have them kind of presented in more detail. Okay, well, I do want to move on to the next agenda item, which is just kind of a breeze through our active studies. We did hear basically about them from Takeo's presentation here. We have 2 active studies right now in SWOG. One is S2000 and one is S1801. Zainab, if you wanted to give a verbal or any slides to share for S2000, please feel free.
So for S2000, I think Takeo had done a nice overview of the study. So again, I think some of our challenges have just been with regards to accrual. I know that, brain mets always does require, a multidisciplinary focus in a lot of institutions. So, and, I know that's been sometimes a challenge at Moffitt as well, at my institution, just with regards to some of these patients, especially with symptomatic brain mets initially being seen by, radiation oncologists or neurosurgeons. So, and, sometimes receiving upfront treatment for all brain mets before coming to medical oncology, or, BRAF status not being known. So I think, I would just encourage sites that have it open to continue to look for patients, and sites that don't have it open yet, to consider opening it, as I think, it does, answer an important question. I think especially for our patients with, symptomatic brain mets, given the rather dismal outcomes that we tend to see even with ipi-nivo immunotherapy for those patients. So again, I would just encourage you to, keep in touch with, the radiation oncologists and neurosurgeons at your institutions, to try to identify patients that may be eligible for this trial.
Zainab, a question for you. Can you ballpark how many sites have opened the trial?
It's actually, I think, well over 100, or actually maybe over 200. I think some sites have a lot of satellites that are included. So I think certainly, number-wise, it's a lot of sites, but I think, it just, I just don't know if the sites have had trouble identifying patients, or if they're still in the process of activating, or.
Yeah, so we'd love to hear from the sites in the chat box. If S2000, if BRAF positive brain mets is a population that you treat and the study is of interest to you, we would like to hear what your obstacles have been locally. But I wonder, Zainab, if it may also make sense to just send an email to those sites. I know what that list looks like when you have so many hospitals enrolled, but maybe send an email and just inquire, we've now been activated for some time. Can you just share what roadblocks you're having? That might help us figure out if it's a awareness issue. We could certainly also consider, digital engagement and figuring out if that's an issue. Yeah, I mean, Kim, your question is good. If patients are on steroids or basically becoming symptomatic and having trouble kind of.
Yeah, I mean, we do allow, patients on dexamethasone, although we did clarify that those should be, stable for a week, up to 8 milligrams dex prior to enrollment. But that's true. I could envision a scenario where a patient needs increasing doses of dex, who may become ineligible. But and again, I'm open to, any further trying to be more flexible with the eligibility criteria. I know we're working on an amendment of the study, so I'm happy to incorporate any suggestions, and I'll take your advice, Sapna, as well, in terms of reaching out to some of the sites and maybe asking about some of the barriers they may have experienced.
Sure.
May I just quickly, I think, would SWOG support us, like Zainab and I may be actually holding a couple of seminars for all of the sites about the study and kind of the data behind it and what's coming along? Soon we were hoping to report Tricotel at ESMO, but had to actually push it a little further. And that's the triplet of Atezo, Cobi, Vem in the first line as well, which is again a single arm, multi-center open label study, but it will give us some insight into whether triplet has, what kind of value it has. So we don't have the data to share yet, but it's probably going to come up in the next few months. So I think being able to share some of the, developments, we also, Kim presented the 3-year data from Checkmate 204 as well, which showed, and you guys will see in the Lancet Oncology paper, it's in the supplement, Kim couldn't present it at the time, that getting an intracranial response at 12 weeks from Ipi/Nivo was associated with a 92% overall survival at 3 years. So there's a lot of, kind of really cool new things to probably share. And I think the concept of just educating some of those sites, I think would be potentially of value. So if there's a mechanism to do that, I'm happy to jump on calls with Zainab to make that happen.
What is the ask, Hussein, if SWOG would support you doing the presentation, or
like seminars or something to the participating site, like just invite the people that open the trial to a separate 30-minute, kind of call and just kind of discuss data and issues, if that's something that we could to Chris and Katrina here. I see sometimes on the agenda these kickoff meetings and launch meetings and things like that. And of course, Zainab is our digital engagement committee member. Is that just something we could set up as a kickoff or an introductory meeting?
Certainly. I mean, those type of things are often in conjunction with the group meetings, and often when they were in person. But I think we can think outside the box with our digital format. It's usually kind of like, it's gathering cats, or whatever the term is, herding cats, right? That's why the group meeting is a good time to do it. But if there's some other form that you can think, or when people might be on, I think that's something we could do. And there's also these pre-recorded things too, as well. That's been done. That's another option too.
When you do these sessions, I think it'll be good to have like the entire team that treats brain lesions on it, because I think often, even though medical oncologists are really interested in prioritizing systemic therapy, the understanding of the efficacy of that is not as high, understandably, outside our field. So I think, and I think often when people then do hear the data, because why would they hear about it? They don't come to our meetings. They're actually very impressed. So I think that would probably be helpful.
This is a mantle Hussein has had to bear for some time, really, right, Hussein? Like the systemic therapy can supplant, traditional thinking as far as treating of brain mets. So
we're very careful about the messaging stuff now. We say, cooperate rather than but absolutely, at a place even like MD Anderson or radiation oncology, people have led multiple multi-center trials for SRS and are kind of leaders in their field. It is about a kind of daily reintroduction of the results and their ability to help patients. So it's a culture change is not going to happen easily, but I think that's the idea of just visibility. And again, those 200 sites that decided to open the study must have had a modicum of interest to actually open it. So maybe kind of harp on that and just try to reinvigorate it. Anyway, I mean, that's, at least Kim can tell you that when we were running Checkmate 204, that actually did work by getting everybody on a call every 2 weeks to talk about, Checkmate 204, and that helped with accrual, and that helped people think about it. So it may be using old tools in a new way, I think, at this point.
Might be good. I assume this hasn't been presented at the Radiation Oncology Committee.
Yes, as long as you promise no tomatoes will be thrown.
Well, I mean, that's like going right to it, right? If they're kind of the gatekeepers for a lot of these patients, that might be a good idea. Just one of the calls.
Sure.
That's a great idea.
I was just going to jump in with regards to the comment in the chat box about eligibility due to SRS. So we have had a couple patients, and also seen by radiation oncology and neurosurgery up front, where they were concerned about maybe a couple of the mets given the location, that actually underwent SRS, but then still, because we were in communication with the radiation oncologist, they left behind at least one untreated brain met that was 0.5 centimeter, and therefore the patient remained eligible for the study and was subsequently able to enroll after the SRS. And again, if the patients had prior SRS and had still, subsequent growth of the brain met, then the patient would also be eligible. So.
Okay, great.
One last quick thing about brain mets, just to inform the group that Mike Pastow and Alison Bitoff-Warren are actually working on a potential brain met study that uses triplet with RELA, so ipi-nivo RELA, in all comers or potentially BRAF wild type, because Sapna, you mentioned that we have that space because this is for BRAF mutant only. So they're already kind of working on that. It's not formal enough yet, but quite ongoing conversations about that as well. So hopefully that will kind of get past all of the kind of usual hurdles before it becomes an actual study.
All right, great. Okay, moving on to our other active study, S1801, our neoadjuvant trial. Enrollment is up to 278 patients, 138 on adjuvant, 140 on neoadjuvant. We have had an update in the pathology chair of the study. It's Victor Prieto for the last year or so, last 6 months at least. And we have caught up on doing some of the pathologic responses. And so we will potentially at spring meeting, if not sooner than that, be able to update everybody on just some preliminary pathology findings. We also I wanted to comment, we frequently get questions about Q6 week dosing of the pembrolizumab on either arm of this study, and this is not allowed. The study is really staying traditional at every 3-week dosing. We really, the pandemic hit, unfortunately, after we had already enrolled about 100 patients. So it would complicate a clean analysis if we allowed different dosing. And then the DSMC will be meeting about this study since we are kind of seeing some events trickle in, and we'll let you know. It will probably not make it all the way to 500, as Takeo mentioned, so we'll keep you guys posted. Keep watch of your email for any alerts about S1801 that would come essentially through CTSU or SWOG. Okay, so we're going to move on to studies that are closed to patient accrual, where we have either heard final results or are awaiting final results, and also we'll have a discussion about the translational medicine protocols in process for those studies. We have about 30 minutes left in the meeting, so I'll see if the speakers can maybe, do your little bits in 5 or 6 minutes or so. We get through about 6 of these studies. So the first one that has been closed to accrual is S1320. This is Alan Al-Ghazi's phase 2 study. This was continuous versus intermittent BRAF MEK dosing for BRAF positive. As many of you guys know, this was a presentation at last year's AACR and of course a publication. So take it away, Alan, and thank you for being available.
There you go. Hopefully you can hear me. Can you hear me?
We can hear you.
Okay, I want to make it really, really short because you know the results of S1320, but I put together, this is what Roger's publication in Cancer Cell using some of our data, and it's actually germane, and it might be interesting to some people because, we talked about sequencing with the DreamSeq results coming in. There was other hints about things going on. So this is showing the effect of an anti-PD-L1 lead-in before MAP kinase inhibitor combination, showing that it increases anti-tumor efficacy. And so the basic highlights are that you see a longer PFS if you do this route of starting with a PD-1 inhibitor and then giving the checkpoint inhibitor, and you have more durable effects. They look a little bit at the biology, showing that you get more of the M1 polarized macrophages in these patients. You see productive immunologic changes by starting with the PD-1 antibody. So the basic, let's see if I can get this to work. There you go. So basically, we've looked at some of these things before. We looked at sequential therapy with MEK inhibitors and PD-1 antibodies, and this is a trial that Tony led. It was published in Nature Communications. But we started with the MEK inhibitor, and actually, by the standard of care, the first approval was BRAF MEK inhibitor first, followed by PD-1 antibodies. So we've been doing this sort of habitually. Now, from the S1320, and this is the one great contribution of the study to this paper, is that we showed that paper had prior exposure to immune checkpoint inhibitor had longer PFS to BRAF and MEK inhibitors when that was given in the next line. And of course, that's completely subjective. It's just amenable to selection bias. There's all sorts of reasons this could be not true. And it's one of the reasons, we weren't sure if this was something that was meaningful or not. But then Roger went and fleshed it out with a lot of additional studies and showed a variety of regimens. This one with the clear line followed by the dark line is that's basically starting with the immune checkpoint inhibitor for a couple of doses and then giving the immunotherapy, and showed that in very many mice that approach led to longer suppression of tumor, longer disease control, increased survival across the board. In keeping with my FAST theme, I'm not going to dwell on this for too long, but then showed there was really an increase in this M1 TAMS, a pro-inflammatory phenotype in this mice tumor samples, and really mostly associated with this regimen of giving the checkpoint inhibitor first. There's a lot of other findings, which I'm not going to go into detail, showing that there's an increase in ratios to the pro-inflammatory, anti-inflammatory macrophages, an increase in cytotoxic CD8 cell populations, an increase in clonality, an increase in the effector to regulatory cell ratios, and an increase in genes, activation genes, checkpoints, and interferon gamma. Interestingly, for this group, there was actually a effect seen in brain metastases as well, and in some other difficult clinical situations, again suggesting that there may be productive changes that start when you start with the PD-1 antibody as a lead-in before you start the MEK inhibitor. And the sort of take-home, at least based on this as described, is if you start with the BRAF MEK inhibitor or MEK inhibitor, you may miss the bus. It may be important in terms of sequencing and in terms of developing a very productive immune response to start with a lead-in of a PD-1 antibody. So this was kind of an example of this. Our study really, added some data to this bench work, and this is really the second publication coming out of S1320. There's still the larger sort of translational work coming from the study itself.
Great. Alan, you don't know in this study, the Brain Mets Association, did they look at P10 loss, and would P10 loss say that you still need your PD-1 antibody first?
They didn't look at that formally, and I think that would be an interesting thing to explore.
Great.
There's a lot of data in that paper, so I welcome everybody to go back and read it. I wanted to give you the brief summary, and also not get myself lost in weeds that I can't identify.
Thank you. Okay, let's move on. I'm just checking the chat, see if there's any questions. I don't see anything. Okay. S1512, Kari Kendra from Ohio State. Again, a demonstration that we can do, rare cutaneous malignancy trials here in SWOG. Kari, I don't know if you had, yeah, perfect. Go ahead.
Okay. Can you see my slide?
Yes. Yes.
Okay. Again, this is the phase 2 trial of PD-1 blockade with pembrolizumab in patients with resectable or unresectable desmoplastic melanoma. There were 2 cohorts, just as a reminder to people. Cohort A was a resectable group. Those received the therapy as a neoadjuvant, pembro, given 200 milligrams IV every 3 weeks for 3, and then underwent resection. Cohort B was the unresectable group. They received the same pembro every 3 weeks until progression. The primary endpoint for the neoadjuvant one, the resectable cohort A, was the pathological complete response rate. And then the primary endpoint for cohort B, the unresectable group, was the complete response rate. Sorry. For this, we have reached accrual. We are currently working on the analysis of the clinical aspects of the study. We do have a few queries that are outstanding. So institutions where you've received the queries, please answer them so we can go ahead and complete our clinical analysis of the samples. And then we can then share the data with you once we have the final clinical data analyzed. In terms of the samples, Katie Campbell has been working very hard with our sample analysis. When we look at it, we do have our patient enrollment, samples are collected, and then it moves on to Katie, where the nuclear acid extraction is done, sequencing library preparation, data is generated, processed, and analysis occurs. For our S1512 sample and data update within the blood, and we do have the West data from 33 of the 52 patients. With the tissue samples, and we do have 53 patients where we have the nucleic acid extracted. 44 of the 136 tissue samples, we have the West done, and we have an RNA-seq for 35 of the 136 tissue samples. So an incredible amount of work done thus far under Katie's hands in the initial sample preparation and generating some of that data.
Is it pre and post tissue, may I ask you? Or do you have, these like 44 and 35, you've got pre and post for your resectable, or are these all?
I can't tell you the balance of exactly what she has, but we have requested pre, we have requested in the middle of therapy for those who are on the unresectable arm.
Okay.
And then for the neoadjuvant, we do have pre, and for those where we do have post, we have tissue there. So it's not a full cohort, in part because of, we did see some responses. But we did get pre, and then the metastatic was in the midst of the therapy for those where we could access them for biopsies. Okay. There is, this is just the analysis pipeline that she is working with. And this slide will come up again with Siwen's and with Ari's talk, so I will defer that then to their discussion as well. So for accrual, I'm sorry, the date is wrong. I forgot to take that off. But we do have had nice accrual from various centers. And a thank you to everybody who contributed, particularly the high accruing sites such as Moffitt and Utah. So thanks to all of you for your hard work. And hopefully we will have some more data and conclusions to tell you with the next meeting. Thank you.
Great, thank you. That tissue submissions for the sites who haven't already, that'll become really important to fatten up that sample size for analysis and pathologic review. All right, S1607, Siwen, this is for our PD-1 refractory patients. This was TVAC.
Yeah, I just want to add to Carrie, we have some really nice dramatic response pictures of patients on 1512. It's actually pretty fun to look at. I probably would just talk like this. I don't know how to share this, how to make it. Oh, is that full screen now?
I see a black screen. Oh yeah, full screen, full screen.
Looks good. Perfect. Okay. I always have trouble here. So this trial, 1607, I think this audience, I can just go through this very quickly. So this is our trial taking melanoma patients who have already progressed on anti-PD-1 and give them TVAC plus pembro, and everybody gets the same treatment. So this is the rationale. We hypothesized that adding TVAC can help reverse the T cell exclusion, bring T cells to the tumors, and help to mount a anti-tumor immune response in those resistant patients. And these are two examples of response. For patient treated on this trial, top one had a huge tumor that Tony treated and had a pretty good response over a period of time, over a couple months. And the bottom one is a patient with a lot of tumors. Each one is rather small, but we have to actually measure each one and inject them. And in the end, it's a complete response there. So TVAC is modified herpes oncolytic virus, and it's already approved based on the Optum study showing benefit, showing durable response that's superior than GM-CSF, relatively safe. And also the phase 1 portion of the MasterKey trial run by Amgen showed, presented by Tony a couple years ago, showing that when you combine TVAC and pembro in the frontline setting, you can induce a pretty good response rate, and there's evidence showing there's a T cell infiltration into the tumors. However, we also the phase 3 portion of MasterKey presented, I think a few weeks ago, showing that it didn't meet its primary endpoint, and there's no statistical significant difference between the two arms for both progression-free survival and overall survival. But subgroup analysis does show to be in the USA has some advantage for good response. It could be just the cohort from US is smaller than the non-US sites. And to have a smaller disease burden measured by LDH or just the size of the target lesions, if it's smaller, then there is advantage to benefit from pembro plus TVAC plus pembro. So I think this trial, it's kind of remind me of the IDO inhibitor phase 3 trial. I think it tells us, to have a randomized phase 3 trial without the biomarker selection is just, destined to fail, especially for this kind of combination management. So I think, this is actually a good rationale for as 1607. It's, I wish they wait until we have the results from 1607 before they design the phase 3 trial. Then we can actually provide a lot of information, because we collected a lot of tissue during this trial, and that's really the highlight of 1607. So in this trial, we have 2 arms, 2 cohorts. Cohort A, patients have measurable visceral lesions, and cohort B, patients don't have visceral lesions. And our primary endpoint is objective response rate, and then we do look at other parameters as well, especially durable response rate. The trial is already completed, and I just want to thank all the sites that recruit patients to this trial. We had to get over a lot of regulatory hurdles at the beginning, because TVAC requires biosafety level, biosafety committee approval at each site. So there are only a few sites that could participate, but we were able to have steady stream of enrollment. And currently, we're still analyzing the data, putting the manuscript together. So this is just some demographics of the, of the different arms, of the 2 arms. It's looks like, and also the patient who can be evaluated for response and safety.
Siwen, we have just 12 minutes left and 4 more studies to go. I wonder if you can just jump to maybe the TM analysis that you're working on.
Yeah. So and we have a lot of tissue collected, and this is the TM study goals and stats. And I think it's in the end of the day, we want to confirm pharmacodynamic confirmation. And, we want to look at all these different parameters and, look at the change in the injected and non-injected lesions. And then we have several, panels so that we can look into the tumor microenvironment. And there are exploratory data points that we're collecting. That's what Katie from Tony's group is working on. So these are just repetitive slides. And I want to thank, all the people who have contributed to this trial. And I want to use 1 minute, just want to introduce, just talking about biomarkers, want to introduce the IMAGE palette, just 2 slides. So we have this protocol under development, and it should be approved by CTAP soon. So we want to, it's a pilot for the IMAGE platform, and where we are going to use prospective biomarkers for development of combination immunotherapy strategies. And here in the pilot, we mostly just want to test the feasibility of this approach. So we will take patients, melanoma patient and head and neck cancer patients who have already progressed on anti-PD-1, and give them a combination of cabozantinib and nivolumab. And the key here is, all patients will need to have a mandatory biopsy, or if they have adequate, archival tissue, that's okay. Then, we're going to put them into different biological categories based on TMB and the GP. There are two stages of this trial. In the first stage, the first half patients, they don't need to wait for the results of the biomarker study before they get treated. And in the second stage, they have to wait because we want equal number in each category. So that can be a little challenging, but we're just exploring the feasibility here. So the trial should be open soon. Thank you very much.
Thank you, Siwen. And, this iMatch development was actually discussed at plenary for those of you who saw plenary session yesterday. And for those of you that are interested, I believe, Siwen, Immunotherapeutics Committee that you co-chair is actually open, right? It's available tomorrow for people to attend in the morning.
Yeah, absolutely. Yeah, anyone is welcome to join the immunotherapy.
So you guys can still go to the SWOG site and register for Immunotherapeutics Committee. You'll get the link to your email, and then you can attend and hear more about that first iMatch study.
Absolutely.
Okay,
yeah.
Ari, thank you for being so prepared. Go for it, S1616. And by the way, I just want to whet everybody's appetite to stay on. We're going to run a little long here. Bartosz is at the very end is going to give us an update on the DreamSeq trial. So just what we're allowed to say publicly.
So I promise I will take 2 minutes. I will not go through 18 slides. Just a quick reminder, SWOG1616 is looking at the combination of Ipi-Nivo in patients who progressed on either PD-1 therapy alone or PD-1 with a non-CTLA-4 combination study. As
it's in presenter view, not full screen, just FYI.
That's really annoying.
Yeah, that's okay.
Well, you know what? It doesn't matter.
It's the top display settings, but anyway, okay.
Yeah, whatever. So I mean, just as a reminder, we did ipilimumab or Ipi plus Nivo. It was randomized 3-to-1. We fully accrued the study in June of 2020, and we're now just waiting for results to come back. But in the meantime, as you can see from the bottom here, we did really well in terms of sample collection. This is a slide that you can see. We're working with Tony Rebus's lab and Katie Campbell. We have really good sample collection from across the United States on this study. I just wanted to point out that we had both archival tumor tissue in more than half of our patients, but also baseline tumor tissue and on-treatment tumor tissue in a large majority of our patients, as well as blood. So we have a huge amount of translational data that we're going to be able to work on. And we've been recipients for this study, recipients from Stand Up to Cancer and AACR of a $3 million grant that has gone both to SWOG and to the Rebus lab in order to really look a lot at translational markers that are going to be on this study. And so we're really excited. As soon as we start getting some clinical data out of this study, we'll be able to start launching all the translational outcomes. And so I expect that the year 2022 is going to be a very busy time for the output of this study. And that's all I have to say.
Perfect. Thanks, Ari. I do want to remind everybody that 1616 is going to answer some very important questions for PD-1 refractory patients. It will be the only randomized trial prospectively to answer, one versus the other. It's not a single arm study. It's randomized. It's not retrospective. And then the vast quantity of biomarker data that they're looking at in this study will also help answer some of those questions that, even if clinically we're not necessarily powered to do so. So I think, stay tuned for 1616, like Ari said. Okay, moving on to S1404. The update that I can give you guys here is that the manuscript has been submitted, and we have recently received some reviews that we will be addressing. And really, it's time to talk about the quality of life manuscript, which is underway. If you guys didn't see it at ESMO, it was a poster presentation where we determined that the quality of life was superior on the pembrolizumab arm, essentially every point at baseline. Isn't that interesting, at baseline? And then everywhere along the way. And so we did it at, I think, 3 months, 6 months, 9 months, and then at progression. This is, it's an interesting thing to ask yourself, does quality of life matter for RFS? when maybe there is no OS benefit. But I think as we hear from patient advocates, this is what they're contemplating in this situation is what is their quality of life, and do they, does one treatment over another impact that? So that manuscript will be forthcoming soon. And really now we're looking at the TM. So we've got several translational medicine proposals underway, and we're going to hear from Ali Grossman here about a pilot study that's being done with Natera on 100 samples to get a look at their circulating tumor DNA assay. Ali, take it away.
Sure, let's see if I can share screen here. Okay, can you all see that?
Yes.
Okay, so I'll try to fly through this. I'm the pathologist helping out with this project because it's circulating tumor DNA, and there's some pretty significant specimen requirements. And the focus, and of course it won't advance. Hang on, I'm gonna have to reload this. So the focus of what I'm gonna share with you today is very briefly, if I can get through the slides. I may have to do it this way. So just as a reminder, the 1404 has multiple arms, and the goal of the Ctdna study is really just to ask some very basic questions, and that is, is there any association between pretreatment circulating tumor DNA, either present or absent, or their levels with relapse, and that's kind of the fundamental point of this study. Now, just to give you an update, a lot of, we've been working on this for 2 years. So patient sample selection by the SWOG biostats team, Megan and James, they were very helpful in helping us understand the limitations of the specimens, and I'll get more into that. And then Nationwide Biobank did all of the processing so that the nucleic acids extracted from Buffycoat germline and from tumor would be available. The frozen plasma was sent right to the testing lab, Natera. And basically we had a sequential attrition of patient sample sets that I'll describe to you a little bit. Probably the biggest my impression has been was up front, and I'll explain why with a selection of patient sample sets. And then the next step in the workflow is actually morphology review of the tumor, because tumor input is required to identify clonal somatic founder mutations. And there are input requirements for that. Then there's a few that also are identified as inadequate at the stage of extraction by the biobank. And then Natera, of course, has a few. The bottom line here is all of the samples that we were able to identify that are eligible and adequate have been sent to Natera. They've done 69 patient tumor germline pairs that have been successfully sequenced by exomes, and they've successfully completed plasma testing for Ctdna on about 29 of those sample sets. And again, we're talking, the sample sets include germline DNA, tumor, and then also plasma. Okay, so the first set of the major attrition was in selection of the sample set. So ideally, the intent was to do this on the pembro treated arm. However, there were not enough patients for 50 cases and 50 controls. So 50 patients that relapsed and 50 that were alive without relapse at 2 years that met all the specimen requirements to proceed. So we moved to the IPI treated arm, where we almost got there, is the bottom line, with a total of 100 patients. And here's an example that James Moon had sent just to demonstrate. So as he queried the inventory for specimens that at least at baseline, the plasma met the minimum volume requirement, which is 4 mils. 10 mils is ideal, but 4 mils. You can see in yellow, so all these patients that have at least 4 mils of plasma, how many of them, and this is, you know, I just pulled a few from his Excel spreadsheet, how many of them had 0 unstained slides of tumor in the bank. So we were just rapidly losing patients here. Ultimately, by the time the workflow came to my stage of morphology review and for adequacy and selection of tumor for enrichment, I ended up reviewing 177 slides from 144 patients. And in the end, we got down to 114 eligible patient sample sets, where about 26% of them were inadequate. And that's just the tumor part of it. And highlighted in yellow here, I just want to convey that I really tried to be, even with the borderline cases, very aggressive. And, you know, of those that required macrodissection to meet those minimum inputs of 30% tumor nuclei in the specimen, some of those were so borderline in terms of the amount of tumor tissue available that they failed to make the minimum requirement of DNA input. And we had to push Natera on this. They wanted 750 nanograms, and we said we can give you 500. And then there were so many that didn't even make the 500 mark because the tumors are so small sometimes, that they were willing to take 200 on, I think, about 25 cases. So we recouped a few there. And I wanted to point out, for those of you interested in future genomic studies, especially Siwen, she had pointed out that these dual DNA RNA extractions of tumor, that at some point someone may want to be doing transcriptome work on that. So it was a little tricky. I had to balance really conflicting needs of different studies. The Natera study, ideally you would want to enrich for as much tumor as possible, even though they only require 30% tumor. Your confidence in the calls in an exome where you don't get a lot of read depth would be better with higher tumor content. But I really did try as much as possible to capture tumor microenvironment for transcriptome studies, and that's illustrated in that picture here. Okay, so I have some examples here, but we don't have to spend a lot of time. This is the one I think that why they fail the most. I get a big, I'm reviewing a big wide local excision, and you know, here's the scar from where the biopsy was, and I have less than 1 millimeter squared or no tumor at all that was submitted to the biobank. And in a lot of these specimens, when you look really close, what's even left in here is, you know, just a sliver of tumor and a lot of, this is, you know, a band of TIL here. So this very challenging to do this study. But we're rocking and rolling now with Natera. Overall, they have 92 sample sets, and they've had a few dropouts for QC issues or failed library preps or whatever. So I think for what they have, it's going well, is my understanding. And I think they'll be done sometime in November. Hats off to everybody behind the scenes involved. I just really want to actually highlight Erin Grundy, the SWOG coordinator at the biobank. I work primarily with her, and she is the fastest emailer responder I've ever seen. She's amazing. She's been fantastic.
And she's here. So thank you, Erin, for you know, helping with the QC of what is in the bank. And Allie, truly, I mean, it becomes apparent now seeing you go through this. Is just 100 cases, and look how much work that was. And this is a large data set. So the opportunities are huge, but the workload is also pretty huge for this kind of stuff. So looking forward to that first pilot study from Natera. Okay, Alan, if you want to blow through S1221, another one of your BRAF study babies. I know we have the data from LabCorp on this, so I'm not sure if there was anything that you were able to look at. Is he still here, Alan? Where's he gone? Okay, well, we might skip S1221 then if I don't see Alan here anymore. All right, the update on that study, this is MEC-AKT, and there was some outstanding pharmacodynamic work, I think, with LabCorp that we just got back. Okay, and then last but not least, we all saw the announcement that DreamSeq finally has the ability to read out, albeit a long, I mean, truly it was a dream doing that trial and of course, waiting for the results. So Bartosz is our SWOG chair of that study and is going to share what he's allowed to share on EA 6134. You're muted, Bartosz.
Unmute. No,
Okay,
now. So of course I cannot, as you can imagine, I cannot tell you probably too much, but what I can tell you, this is the design of the trial, you probably know. BRAF mutated melanoma patients were randomly assigned either to immunotherapy, nivolumab, ipilimumab combination, or dabrafenib and trametinib. It's a first-line treatment. Patients with asymptomatic brain metastases were allowed on this trial. And as you can see, initially we started with a standard nivo-EP regimen. The alternative regimen was allowed with amendment, something like 17 or something. And then at the time of progression, patients were allowed to cross, they would cross over to targeted therapy or immunotherapy. So, of course, this is our sample size, and I think probably is the most important slide. Our sample size was supposed to be 300 patients for 270 patients eligible. And in this study would give a 90% power for the endpoint of 2-year overall survival, with the difference of 70% in arm A and 50% in arm B, with two-sided type 1 error rate of 0.05. And we started doing our interim analysis at 33% information time, and by information time we call a 2-year overall survival. So we started doing interim analysis when 33% of patients achieved 2-year overall survival. So, as you know, it took a long time. 2015 activated with a short hold. At the end, actually, 267 patients were enrolled, and 20% of these patients were enrolled by SWOG. I think we had 55 or 54 patients. And we plan to enroll at finish of February 2023. So the fourth interim analysis, which you see here, took place about 4 weeks ago, and we met with data monitoring committee a few days after interim analysis, and at that time 59% of patients had a 2-year overall survival. And based on this, the study met its endpoint, and with a significant improvement in 2-year overall survival for immunotherapy over targeted therapy. As I cannot share these curves with you, but I can tell you when the separation started about 2 months after initiation of the therapy. So based on this, of course, we recommended that when enrollment be stopped, and also patients who are currently on targeted therapy as a first-line therapy will be allowed to cross over to immunotherapy. This is, of course, a decision of a treating physician and a patient without waiting for progression. Of waiting for progression of the disease, and at some point we will be able to switch nivolumab. So the study will not continue to enroll, will not, but we will still, patients who are treated, of course, will continue receiving the treatment, and we will be able to switch probably to nivolumab 480 milligrams every 4 weeks for convenience. So just I said, you know, the endpoint was a 20% difference in overall survival at 2 years. And that's all. All the correlative study, nothing is done. You know, as you say, we had just data monitoring committee meeting.
Bartosz, you mentioned that the separation started around, was it 2 months or 10 months?
10 months. 10 months.
Okay, that's
10
very
months.
interesting.
Okay,
yeah.
sorry. It's around 10 months that the curve started separating.
Bartosz, quick statistical question. So you had 4 interim looks, which means that the p-value for that difference must have been incredibly low, right?
p-value, yes.
Okay, interesting.
Yes, so I'm just saying, this was actually pre-planned, this interim analysis were pre-planned. And initially, it's a little bit, as you can imagine, the study is tricky because of the crossover. So obviously, I mean, statistically trickier because of the crossover, because the progression events happen, and then the patients go to the other arm, so it changes you when you look at the survival. Sometimes they are still on the initial arm, sometimes they are already on a crossover arm, which makes it, for statisticians a little bit tricky. That's why we chose as an endpoint somewhat a remote point from the initiation, when either you are doing well or you crossed over. But initially we tried to look, and this difference could have been seen probably even sooner, but just we were looking at the events kind of in a little bit real time, and that's why with this is called this O'Brien-Fleming boundaries, and this kind of mudded initially the picture. Then we looked at it a different way, and it was clear what's happened. Sorry.
Thank you.
Well, that's great. Thanks everybody for sticking with us a few minutes long. I'm going to learn how to get these meetings better.
You owe us half an hour, Sapna.
Right, I know, 20 minutes yesterday, 10 minutes here. I'm so sorry. Just an update that spring meeting is planned at this moment to be virtual, and it will be moved to Seattle for those of you that hadn't heard.
Not virtual.
No.
Oh, great.
I'm sorry, did I say virtual? It's planned to be live. I'm sorry. I'm used to saying, to saying virtual.
What are you?
April 8th, I think, and 9, 10, something like that. First week of April.
Yes, yeah. So Seattle, we hope to see you guys there. We're going to use those Hope Foundation funds for a really nice dinner to get together.
Canless.
Okay.
Can you circulate the dates and times?
Sure. We sure can. And a special thank you to our SWOG hosts, of course, our audiovisual support for the last 2 days, Katrina, Courtney, everybody that's helped us support this meeting. Thank you guys so much. We did have transcripts for the speakers, so we'll be able to share that. And yes, one final word about the social this evening.
Yes, we're looking forward to seeing you. Instructions are coming your way, and this is just to show that it takes a village.
Thank you so much for organizing this. I can't wait.
Thanks for the chocolate.
And proof that once in a while, life really is a box of chocolates.
Oh, Vern.
Yay.
Okay, everybody, see you tonight, or see you hopefully in Seattle.
Yeah. Bye.
Bye.